kind of close to that one. And then we were going to sketch some graphs. I think that was our big deal. Okay. That was our story. The only other thing I said, do you remember the log of each of these and sketching those graphs? So if I go back, log base 5 of x, wasn't anything special about that one, but I want to talk about some key features. So if I graph this one, bam, bam, and I look for a log graph, log graphs always look like this if they're untransformed. So nothing fancy, there's your log graph. They cross, if they're untransformed, they always cross at 1, 0. Okay. And the other part, there's one other value you know really well. Do you know what I could put in for x that I could easily tell you what the y value is? You guys know any good values? This is 1. Is there a special place I could go on this graph? Like the log of some number you know? You know what the log base 5 of 2 is? Log base 5 of 4. What about the log base 5 of 5? Kobe, you know what the log base 5 of 5 is. Five to what power makes 5? Better put it in pink. 1. 5 to the first. So the same base log, the one other value we know is if we go out to 5 here, we get this point, it'll cross, it'll hit 1. So this is the point right there, 5, 1. So if you go to the x coordinate that's the same as your base, it will hit at a height of 1. And that gives you a nice picture of your log. Pretty cool, huh? So I'm going to do the same kind of idea, and I'm going to go to the 1/4 log. Now we played with this yesterday. We tried to generalize. It was new to us, but we can make this happen again. Okay, so here comes the log. Now this one went differently. Remember, it was a different direction. Didn't look the same. If you have that in your mind, I'm going to make a little table here of things that I know. X and Y, and we'll plot that first. I bet you if I put in 0 for x, I'll get an error. It's the same thing. You can't put in 0, you can't put in negatives. If I put in 1 for x, that's the same thing as saying 1/4 to what power equals 1. And the only thing we can raise it to, it's kind of hard to see this, but 1/4, I could also do this way, to the y power, to the first power, makes x. The only thing that works for that is 0. Okay, 1/4 to whatever the log's equal to, that's your power, to the 0th power, makes x. So there's one point that we know is that we go out to x equals 1, and your graph hits that way. Okay, so I'm going to delete some other stuff so I can see this again. That's the basic log conversion business. Another easy point we could put in there, remember 1/4? If you put in the same number as your base, so if I put 1/4 in here, that's asking 1/4 to what power gives me 1/4, and it has to be the first power. Y would have to be the first. So if I go to 1/4, which is right in here somewhere-ish, I'm going to hit a height of 1. Now that's weird. I'm hitting these 2 points, and you kind of know the shape. Do you remember a log of a fractional log has this weird look to it? It was like an upside down regular log. Okay. And there's probably maybe one other place that you know really well. If I put in 4, I'm thinking 4 to what power, or 1/4 to what power gives me 4. I'm going to do this real fast. 1/4 to the y gives me 4. If I put 4 in for x, that's what I'm doing right now. So I'm thinking of it. All right, let's put 4 in here. 1/4 to what power gives me 4? Remember that one's the flippy power. It's the -1. I have to raise it to the -1, turn it over. Okay, so if I go out to 4, 1, 2, 3, 4, I'd hit -1. Okay, so that's a picture of my graph. So when you peek at those, yesterday we just talked about having a base that's a fraction just turns a log upside down. But that's more about y, so you make a little table. Those are the values that go into it. Being able to graph a basic log, muy importante. I had to translate that for you, Evan, that means very important in Spanish. You look mixed up. Even though you speak fluent Spanish, don't you? God, man, you kids are sharp. Okay, let's do another one. Log base 4 of x minus 2 plus 1. So here's what I'm going to do. We're going to be really boring and graph. Boring log base 4. Oh, so boring. Look at that dull graph. Okay, so there it is. I know it goes through. This is the point 1, 0. Oh dear. What? I don't even know quite what that is that I just wrote, but I think it was supposed to be 1, 0. There you go. And you know, if you put in, now log base 4, if I put 4 in for x, that's 1, 2, 3, 4. We're out here to 1, 2, 3, 4. There's a height of 1. If you go out to 4, your height should be 1, because log base 4 of 4 is 1. So that's a point we know for plain old boring log base 4 of x. Then we can go mess with it and do this stuff up here. And we'll do all the fun stuff in pink, because that's what pink is. Fun. We're going to take it right 2. Bam, bam. And up 1. Bam. And that means my vertical asymptote goes right 2. And my graph goes up 1. And so watch this. Same beautiful graph, but I took some key points, moved it right to up 1. The 2 key points that I graphed that were in blue before, so should I go show you those? Remember this point and this point right here? Those got moved to their new location over to up 1. I moved them to their new location right to up 1. And the other part that was really, 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 really important, emphasis on the really, is they moved the whole vertical asymptote, had to go right to. Have to move the vertical asymptote when you go right to. That is crazy. Crazy. I'm going to slide this over so you can see the next one. And natural log of x plus 1. We got to go simple after going complicated. There's natural log of x, which by the way still goes to the point 1, 0. So this is ln x. And it goes, if you got to the point E on your graph, it hits a height of 1. E is 2.71. We're going to talk about E today if we have some time, because E is cool. So we got to E. Take that over. That's a height of 1. This plus 1, y'all know what that means. It's pink time. Left 1. So everything gets moved left 1, most especially that vertical asymptote. So this goes left 1, this goes left 1, and my asymptote went left 1. So now I'm going to cross one spot to the left. E gets moved over a little bit, and your log graph still snuggles up against its vertical asymptote. So just got to snuggle. Make sure you moved your vertical asymptote. It's muy importante. Again, muy importante. All right, we're going to scroll. That's what we did yesterday, and that's a little more technical version of what we did yesterday. So if you're good yesterday, this is just icing on a very scrumptious cake. Okay, so shall we continue on? All right, you know you wanted to get here. This is the solving stuff we briefly got into. We're going to solve like there's no tomorrow. Get ready. Get perky. Right, Naban? Get some coffee. It's cooling off. I turned it off, but grab some if you need some. Okay. Solving. If you have to solve an exponential like these guys are logs, you either get the exponential alone, you isolate, get log alone, isolate. If you really want to figure somebody out, what they're like, you got to get them on their own. You got to isolate them. You put them in A room, a padded room with no windows. You find out what, that's kind of cruel. No. In psychology, you put them in a room and you find out what you're like. If you're set by yourself, nobody watching, take away all your fun things, you find out what kind of person are you really. Am I creeping you guys out? I'm trying to make an analogy for getting the log and the exponent by itself. So you can find out, solve this thing, get to the bottom of the matter. Don't turn me in. Now let's do this. So that means I'm going to divide by 20 first. Divide by 20, divide by 20. Because I want that 1/2 to the x over 3. Now, if you guys read this, I'm gonna pause here for just a second. This is like a half-life problem. This would be like my initial value, 20. And do you see that 1/3 up there? It halves every 3 units of time. So if this were days, this is halving every 3 days, is what it's saying. That little, remember that divided by 3 we were just dealing with in your quiz there? This bad boy halves every 3 days. That's what that 1/3 in the exponent means. Okay. And what I'm trying to find out, this particular equation says to me, hey, if I start with 20, how long until I have 5 units left? It's actually what this whole doohickey says. How long until I have 5, starting with 20, if my half-life, if this thing halves every 3 days? Isn't that kind of cool? Well, those are the kind of problems we run into, and this is how we solve it. You divide by 20 first. 1/2 to the x over 3. 5 over 20 is a 4th. Awesome. And now we're in the point where I gotta find out. I gotta get that x out of there. It's stuck. And that's when we employ logs. Once the exponent is isolated, I got some number to a power, then I can take the log of both sides. And so enter in the log, and because we're getting to the fun stuff, it's gonna be pink. See? Log, log. And then I can pull it out front. You know what I'm saying? And then we can take and divide out the, you guys did this really well on that quiz. I was really impressed. We're trying to get to x. This is a setup now, it's just isolating x. So divide by log of 1/2, it's a number. If you can get comfortable with log of a number is just another number. It's nothing fancy. I wouldn't get the decimal too early because you're going to round, and if you round early, things start going wonky. So I'm divided by log of 1/2. Got to multiply both sides by 3, and we are on our way. 3 ln 1/4 over ln 1/2. Stick it in your calculator, get a decimal, and that's an approximation. Actually, those are pretty nice. Decimal isn't too bad. I'm going to move on to the next one. Start in blue, boring blue. Isolate the log or isolate the exponent. Done. I got an isolated log. There's nothing, there's no numbers and frilly stuff around it, so it's ready to roll. So we can go to pink because it's fun time. To solve a log, you convert it to exponential. So do you see that solving exponentials required using logs? Solving a log equation requires converting to exponential. There's no base written, so it's 10. Okay, so we're converting. 10 squared makes x squared. Now if you're really savvy, I got 10 squared equals something squared. I think the something has to be a 10 if these are actually equal. But we can solve, we can do other stuff too. We can, that's 100. I mean, if you want to be, you can do this. But I would just say I'm done. I got x equals 10. That would be me right now going x equals 10. Ha! Take that. But others of you might say, wait, Mr. Seeley, isn't it plus or minus 10? Because I took the square root of both sides like you told us to do way back in the beginning. When you introduce a square root, it's always plus or minus. And you'd be right, I guess. So really this is plus or minus 10. Because it could be 10, I mean, really? Couldn't it be the same thing? Isn't 10 squared the same thing as negative 10 squared if it's in the x there? But then you look up there, when you get more than one solution, you test them out. Is it okay to use that solution in the original? are all the answers okay? And you guys are particularly good at finding extraneous. Of all my pre-calc classes, you guys have been very good